Hello everybody, welcome to Maths today where we're going to be adding mixed numbers. Let's start by getting those brains all fired up and ready to go. You've got my arithmetic starter just here. Pause me and then I'll reveal the answers. Okay, so a bit of a throwback there. We haven't done symmetry so much in year 5 yet. Hopefully you've thought about when you've done it in other points in school. 1/3 would be the same as 5/15 because we multiply 3 by 5, do the same to the bottom as the top. We did a perimeter. We did a perimeter yesterday. This is an area. So hopefully you did 7 times 18 to get 126. And lines of symmetry, you could cut it 2 ways with perfect lines of symmetry. Okay, so let's get going with our little fraction warm-up, which is I want you to have a mark on this fraction work and correct any areas. So you're the teacher. Is this person correct? Is 3 2/5 bigger or greater than 17/5? How could you check it? Have a go. Pause me. Right. Hopefully you went, right, I'm going to convert it. So either I've got both are mixed numbers, both are improper fractions. I'd probably go both improper fractions. 3 times 5 is 15, add the 2, 17. So 17/5. 17/5 isn't greater than 17/5. It's actually equal to. This one here, also incorrect. 12/8 is not greater than 4 1/8 because 4 1/8 is the same as 33/8. Okay. This bottom one, though, was correct. Okay, so hopefully you had a go. If you weren't sure, why don't you pause me, have a go at converting either improper into mixed or mixed into improper, and then having a go and comparing there. Okay. So, as I mentioned, today we are going to be adding mixed numbers. Very similar to what we've been doing with adding fractions, just a couple of extra steps. If I ask you though, if you have a look at my question on the board here, on my screen, I've got 3 5/6 add 13/3. And I've drawn a little bar model there to help you. Okay, so what do you think? How would you go about adding those two numbers together? And how could you make sure your answer was in the simplest form? Why don't you have a little go for me? Or have a think about how you would do it. Pause me, maybe have a go, and then come back and I'll show you 2 different methods today. Okay. So you might have had a look and added up our bars. So our whole bars, you could see we had kind of 7 whole bars there. Then we had these 2. But if I added those 2 together, that would actually make another whole bar. My answer is 8 1/6. Okay. But don't worry if you're not sure how we would have got to that point yet, because I am going to show you next. Okay, so we're going to follow some steps. I'm going to break these down a little bit further for you in just a minute, but I wanted to show you with an example first. So we've got here, you can see my answer as well. The reason is hopefully it will help you see kind of the process as we go. So we've got 2 2/5 add 3 6/10 equals 5 10/10, which is the same as 6. Now we can start this by adding together my whole numbers, okay, because that's pretty simple. That's something we've been able to do for a while, am I right? 2 add 3 is going to equal 5. Yeah. The next step is going to be to add our fractions. Well, we've done loads of work on that, and we know if we've got fractions with different denominators, I'm a bit stuck on denominators, then we know we have to convert them so that they're both got the same denominator. I know that 10 is in the 5 and 10 times tables, so I can change 2/5 into tenths by multiplying the bottom and the top by 2. It should give me 4/10. Okay, that's our first step of adding our fractions, isn't it? Finding the common denominator and then converting. Once we've converted, it's a simple case of adding. So I'm just going to do 4/10, which is the same as 2/5, add 6/10, my 10/10. And what is 10/10 equal to? Well, 10/10 is the same as a whole, isn't it? If the numerator and the denominator are the same number, it's just a whole. So I've got my 5 from adding my whole numbers. I've got my 10/10 from adding my fractions, which would be 5 and 10/10, or as we mentioned, 6, because 10/10 is the same as a whole. Okay, let's have a look then with another example. That was quite a quick way of going through it. Let's have a look and let's see if you can do this with me. 4 5/8 add 1 2/16. Step 1, we're going to add the whole numbers first. Can you see which ones are the whole numbers? It's 4, add 1. 4 add 1 is 5. Easy peasy. Right, apologies for the slight spelling error I've got here. I'm hoping you don't mind fraction-ons, okay? So, next we've got step 2, convert the fractions to the same denominators. I'm just going to identify my fractions anyway. I got 5/8 and 2/16. So if I want to get the same denominator, again, I know that 16 is in both the 8 and the 16 times table. So I can change 5/8 into 16ths by, what do? I multiply 8 times 2 to turn it into 16. I do the same to the bottom as the top, and that's going to equal 10/16. So now, instead of thinking about 5/8, I've turned that into 10/16 for me to add. Okay, so now step 3 is add the fractions, convert into whole numbers if needed. So I'm adding 5/8, which is now 10/16, and I'm adding that to 2/16. Okay, 10/16 add 2/16 is going to equal 12/16. Now, the final thing we need to do before we then put those two bits together, can that be simplified? It mentions here to convert to a whole number if needed. Well, 12/16 is less than a whole, but can it be simplified by dividing? Is there a number, a times table that 12 and 16 both appear in? Yes, 12 and 16 are both in the 4 times tables. So if I divide this bottom and the top by 4, 12 divided by 4 is 3. 16 divided by 4 is 4. So that simplifies down to 3/4. Final step 4 is to add the whole number, my answer from number 1, and the fraction, my answer from number 3. So we're going to add 5, add 3/4. Well, that's just going to be 5 and 3/4, isn't it? And when we're adding, if we've just got a normal fraction and a whole number, we could just write that as a mixed number, 5 and 3/4. Okay. Hopefully you can see the breakdown of the steps. Now, we simplified here at the end of step 3. I did that because I was just focusing on the fraction there. There's nothing to stop you from simplifying it once you've done all of the steps. So keeping it as 12/16, 5 and 12/16 is your answer, then simplifying at the end. These steps are on the home learning page. They're going to be really useful for you to follow so that if there's a point you're getting a bit stuck, you can have a little go. Okay, so why don't you pause me, please, have a go at adding together these fractions, following each of these steps, see what your answer is. Okay, so the answer to that question, if you followed those steps and you simplified, you should have ended up with 9 1/3, I believe. If you didn't get that, come along to a daily drop-in session, either with me or Ms. Rutherford, and we'll try and work through that together, okay? Right, another method then. So first method was add the whole numbers, add the fractions, combine. Another way is to convert them into improper fractions to add first. Okay, so if we look here, we've got 2 and 7/9, add 1 and 4/18. What we've done is we've converted them first. So we've gone, okay, we've got 2 times 9 would be 18, plus the 7 would be 25. So 25/9 is what 2 and 7/9 has become. 1 and 4/18, we've gone 1 times 18. Add the 4 would be 22. So now we've got 22/18. So then we've changed it. So we've changed them to improper. Then then we've changed it so that it's the same denominator. So we've got 25/9 is now 50/18. Add 22/18 would be 77/18. Final step, we'd then change that back into a mixed number. So if I flip back here, we split up the whole number, added those, added the fractions. Here, we've changed them into improper fractions. We've then had a go at converted them so they've got the same denominator, adding them before turning it into a mixed number. Why don't you have a go for me at doing that with this question? So turning in both 2 6/10 and 3 4/5 into improper fractions, then adding them and then converting. Pause me here, have a go and think about which method you prefer, okay? Okay, so I just had a go. The answer you should have got would have been 6 4/10 or simplified 6 2/5. Again, if you're not sure, come along to our drop-in session. We can do an example. Personally, having used both, I prefer the first method where you add the whole numbers, add the fractions. But some of you might feel otherwise, okay? Right, what I'd like you to do then is we've got our fluency here. This is also on the website. And I'd like you to have a go at doing this with whichever method you prefer. Both steps will be on the website. So you've got a step-by-step breakdown to help you, a little almost like a recipe to solving them. But also, if you are not sure at any point, come along to our drop-in sessions and we can show you. I will reveal the answers. If you pause me and have a go, and then I'll reveal the answers at the end. Again, they will also be on the website though, okay? Right, let me show you the answers for these questions. If I just whip this along. There we go. So these answers, I believe, they're all in their simplest form. It might be, if you've got something that looks, maybe your whole number's the same, but your fraction's different, I would recommend just checking, have I simplified it by dividing it as much as it will go, okay? Have a little go, come and ask us if you're not sure, but if you're feeling good, why don't you have a go at some of our problem solving and reasoning? I'll see you tomorrow for a little bit more maths. Bye-bye.